So for this video, I'm going to show you an example of Gauss-Jordan and Gaussian elimination. So what I'm going to do is I'm going to solve this system here using each one of these processes. Now, this is really all about using an algorithm, and the algorithm has two steps. So there's the forward phase of the algorithm, and that's Gaussian elimination, versus the backward phase of the algorithm, which is going to be our Gauss-Jordan elimination. And more specifically, so for the forward phase, we're going to just work on getting our ones on the diagonal and then the zeros below. And then for the backward phase, that's where we get the zeros above the ones. So I'll show you all of this, and I'll also show you how you can solve the equations in either form. So I am assuming that you know how to take a system like this, and you just take the coefficients and you set up an augmented matrix. Now for this augmented matrix, sometimes you see augmented matrices with like little lines here, sometimes you don't. I'm just going to omit them for now because they don't matter. Okay, so the whole thing with this algorithm is that you really need to be consistent with how you're doing this. So what I want to do is the first thing is I need to get a 1 here. So I already have the 1 here, so this one's already kind of started for us. Now, you want to be consistent in how you approach this. So even though there's a 1 down here, to technically use this algorithm properly, what we want to do is we want to use this 1 to get these to be zeros. So we don't want to view it as I have choices. We want to view this as an algorithm, so I'm going to do the same thing every single time. So I already have my 1 here, so now I need this to be a 0. So what do I need to add to 2 to turn it to 0? I need to add -2. So what I'm going to do is I'm going to multiply this entire row by -2, and then I'm going to add it to row 2. Okay, so let's go ahead and do that. And for this first step, I will just show you exactly what is happening. So actually, I'm going to do the middle row first. Okay, so what I'm doing is I'm taking -2 times each entry here. So this is going to be -2 times 1 plus 2. And then -2 times 3 minus 2. -2 times 1 plus 1. So notice that I'm multiplying -2 by each entry here, right? And then adding it to the entry below. So the next one's going to be -2 times 1 plus 2. And then I'm running out of room, but I'll try to squeeze it in. -2 times 3 plus 8. So here's everything that I need for that row. Everything else in this matrix is going to stay the same. Okay, now as you can see, it's kind of tedious to actually write out all the work. But the thing is, if you're simplifying matrices by hand, you're going to have to make a choice whether or not it makes sense for you to do this work or to write this work out. Because one of the things I find with this is that people's brains move so fast with the calculations that they make calculation errors. So it's just something that you have to think about. Okay, so I'm going to finish these calculations. So let's see. I'm going to leave the first row unchanged. This row will be 0. Let's see. This will be 0, -8, -1, 0, and looks like 2. Okay, now the other thing is before I move on, I always double check my last step to make sure I didn't make any copying errors, because that is like a very easy thing to do here. So I double check all my math, and I double check that I made no copying errors, and I think I'm good here, so I'm going to keep going. Okay, so obviously I'm going to need some space. Okay, so we're in the forward phase, so I need to get my 1, and then I need zeros all below the 1. So this is the next 0 that I need to get. Therefore, I'm going to take, so I want to add -1 to this. So what I'm going to do is I'm going to take -1 times row 1 plus row 3. So let's see, I will show you the math one more time. So I'll just do it in the bottom. So this becomes -1 plus 1, -3 minus 5, -1 plus 0, -1 plus 1, and -3 plus 5. So I went and I took every element here I made it negative, and then I added it to the bottom row. So that is the process that we are using. And then I just fill everything else in. So in this case, then I'm going to have 1, 0, 0, 3, negative 8, negative 8, 1, negative 1, negative 1, 1, 0, 0, and 3, 2, 2. Okay, so right away you can see what is going to happen here, right? So this row and this bottom row are actually repeats of one another. So, okay, let's clear some space again. And so now I have my ones, I have my zeros, bada bing, bada boom. So now what we're going to do is we want to move down the diagonal. And so what we want to do next is now we would like to turn this into a 1. So what I'm going to do is, so again, I'm just following the algorithm here. So I know that you might think, oh, but I could do this, I could do that. So we just want to follow the algorithm. So while I totally agree with you, you could probably think of a bunch of other ways to do this. The thing with the algorithm is that you have to say, I don't care, I'm just following the algorithm. So this is where I want my 1. So what I'm going to do is I'm going to multiply negative 1 over 8 times row 2. And that will get me a 1 right here, which is the only thing I care about in the algorithm. So I'm going to leave the top row alone. This becomes 1, 1 over 8, 0, and negative 1 over 4. And then I leave the bottom row alone. And now I'm going to use this one to get another 0. So I know you're probably saying, oh, but I could have just multiplied this by negative 1 and gotten this. So yeah, you technically could. That really wouldn't upset the algorithm too much, but I'm trying to really impress upon you that we want to do the same thing every single time, even if it is a little inconvenient. So I just want to get that form of the algorithm in our system. So now what I'm going to do is I'm going to take 8 times row 2, and I'm going to add that to row 3. Okay, so now the top row and the middle row are unchanged. And I know that now what's going to effectively happen is that this is going to just be the positive entries here, right? So when I add these together, I should get 0, 0, 0, and 0. Okay, cool. So this is not a problem. This can happen sometimes. So it happened, all right. And so now in the algorithm, if I want to keep going, so I see that, okay, there are no more 1s that I can get down the diagonal, right? Because this whole row just fell out. So when that happens, now I have to take a look at the matrix. And so now I say, okay, I've gotten all the 1s that I possibly can, and I've gotten all the 0s below. So this is as far as I can go. And so that is our forward phase. And so now we can work on the backward phase. So I have now used Gaussian elimination. So now what I want to do is actually, I'm just going to remember. So I'm going to just note this to myself. So I'm going to note that this is the end of the forward phase. And what I'm going to do next is I'm going to table this for a minute, and I want to finish the backwards phase just to show you what that is. And then I will show you how to solve the equations either from this form or from the other form so that we're about to get. So let me make some space again. Okay, so now I want to work on the backwards phase. So, all right, so now I want to get as many 0s above the 1s as possible, but in this instance, I only have this 1, so this is actually the only other place where I need a 0. So it kind of just depends. If I had another 1 here, or maybe my 1 here, then I would get 0s above those 1s. So you just have to take stock of where you're at. So now what I want to do is I want to turn this into a 0, so I need to use this 1 to do that. So whatever column you're in, wherever you're shooting for, that's the one you want to use. So now what I'm going to do, I'm going to take, oops, let me change my color here. I'm going to take negative 3 times row 2 plus row 1. Okay, so what that's going to do is, maybe I'll just write out the math. So this is going to become negative 3 plus 3. This will be negative 3/8 plus 1. This will be 0 plus 1. And so then this last one will be 3 over 4. So I'm going to rewrite 3 as 12 over 4 so I can easily add this. This will be 3 over 4 plus 12 over 4. And then the rest of this just stays the same. So in the end, I am going to have 1, 0, 5/8, 1, 15 over 4, 0, 1, 1/8, 0, negative 1 over 4, and then my row of zeros. Okay, and so this is now the end of what I can do with this particular matrix, because notice I have all my 1s down the diagonal, and since this is the only other 0 I need above a 1, there's nothing else I can do with this. So this is as far as this particular matrix will go. Okay, so now I want to go back to the forward phase and the backwards phase. So what I want to do is I want to talk about how do you solve the equations in the forward phase and how does that compare to the backwards phase. So let's go back to our forward phase. So what I'm going to do is I'm just going to take this matrix for a second so that we can focus on it. So here is the end of my forward phase. So if you're asked to do this and you're asked to use only Gaussian elimination, so now what you want to do is you kind of want to take stock of what you have in your matrix. So anything that's a leading 1, so maybe I'll just note these. So those are my leading 1s. And remember, this corresponds to x1, x2, x3, x4, and this is what everything equals. So anything that was leading 1 is also going to be a leading variable. So that means that my x1 and my x2 are my leading variables. Therefore, anything that's not a leading variable is going to be a free variable. So my free variables are going to be x3 and x4. Now, depending on the book that you're using, some books make you rename your free variables, other books do not. So the book that I'm using right now seems to like to name its free variables. So since I have these two free variables, what I'm going to do is I'm going to just state to that my x3 is an r and my x4 is a t. I don't like using s because my s's always look like 5s and I get stressed out about them. So okay, so here are my two free variables. The one thing I like about this convention is that I don't forget what a free variable is. Okay, so now that I know where my free variables are, what I'm going to do is I'm going to write each line out in its equation form again. So the top line will be x1 plus 3x2 plus x3 plus x4 equals 3. And then the next line will be x2 plus 1/8 x2 equals negative 1 over 4. Okay, so now the next thing, oops, sorry, this should have been x2 plus x3, sorry. Okay, so now the next thing that I want to do is I want to solve for my leading variables. So I need to solve for x1 and x2. The nice thing about the matrix is that when you get to this point, it's actually pretty simple to do. So let's go ahead and make a little more space again. Okay, so, and actually I'm just gonna note to myself, so my x3 was an r and my x4 was a t. Okay, so the next thing that I want to do is when I'm looking here at my x2, so I just want to replace this with my free variable. This is the one thing I like about actually naming your free variables, is then you don't forget what's a free variable. So this now is going to be an r. So then I can really easily solve for my x2. So my x2 in this case is now going to just be negative 1 over 4 minus 1/8 r. So now that I've solved for x2, I can go back to my x1. So where I had this x2, I'm now going to replace it with this part. So this is now going to be negative 1 over 4 minus 1/8 r. And then we've got a plus r and a plus t equals 3. So now I've just got to like collect any like terms that I have. So let's see, this will be x1 minus 3 over 4 minus 3 over 8r plus r plus t equals 3. So I have x1, let's see, x1 plus 5 over 8r plus t minus 3 over 4 equals 3. Okay, so now let me clear a little more space again. Okay, so now I just need to solve for, here's where I'm at with my x1. So this is going to become, let's see, my x1 will equal negative 5/8 r minus t. So I'm going to rewrite 3 as 12 over 4 so that I can easily add this 3/4 to it, so that my x1 is now going to be 15 over 4 minus 5/8 r minus t. And so now I finally have all my solutions. So here was my x3 and my x4. Here was my x2. And here was my x1. Okay, so now what I want to do is I want to compare this process, and I'm going to go back to now where my, let's see, where was it here? We're going to go back to this matrix, which is where we completed the backwards phase. So what does solving the equations look like in this case? So I'm going to take this matrix. Okay, so let's go through this now. So this is a different matrix, right? But I still have the same leading variables. So this is my x1 column, this is my x2 column. So I'm just going to note that. So my leading are still x1 and x2, so that didn't change. And my free in this case are still going to be x3 and x4. So once again, I'm just going to note to myself, so my x3 will be an r and my x4 will be a t, because my book likes to just use these as free variables. Okay, so same idea. So now I'm going to rewrite each line as its own equation. So this will be x1 plus 5/8 x3 plus x4 equals 15 over 4. And then the next line is x2 plus 1/8 x3 equals negative 1 over 4. Okay, and so now you'll actually notice this is significantly easier to solve than with the Gaussian elimination. So I'm going to replace the x3s with the r and the x4 with the t, just so that I don't forget what's a free variable. Okay, and so now it's actually very simple to finish this, right? So this is going to be my x1 equals 15 over 4 minus 5/8 r minus t. Bada bing, bada boom, we're done. And then my x2 is, I can again really easily see that, so that's minus 1/4 minus 1/8 r. So there you go. So now I have my 4 solutions. So just highlight those. It's the exact same thing. And actually it was a lot less work in some ways to get these solutions. So it's kind of like, how do you want to do your work in some ways? So in this case, I had to do more work to get my matrix finished, but it was easier to figure out the solutions. When we were doing just Gaussian elimination, we had to do more work for the equations, but it was less work for the matrix. But it comes out to the exact same answer. And the last thing that I just want to remind you of is, like, why do we have these two? Well, this is another field in and of itself, really, but it's depending on the size and complexity of your matrix. A computer can often do Gaussian elimination faster than it might do Gauss-Jordan elimination, and then a computer can like easily solve a system of equations from Gaussian elimination. So that's kind of why we have the two, and that's why you want to keep them straight. So that's it for this video. If you found this helpful, I'd love it if you hit that like button or the subscribe button, and I will talk to you guys in another video. Peace.